Next up, let's think graphically. First of all, if I forgot the previous formulas, whether it's plus h or minus h times or divided by the factor, how can I figure that out? Well, the trick is to think about points. Suppose I want to move the left function to the right and up by 2 units. How can I do it? In particular, if I move it to the right first, do I get fx plus 2 or fx minus 2? Well, the key point is that in this new function, this point 2, 0 is almost like the original point 0, 0. Well, 0, 0 must be transformed here. So, what would be the right form of the function that gives a value of f of 0 at 2? Well, look at this one. F of x minus 2, which is f of 2 minus 2, is actually f of 0. So that's just like the original point. Whereas this one would be f of 4. So that's not the original point. So if we think about a particular important point on the function, and we look at how it transforms, well, then obviously we can substitute it in and see if we get the original value or not. Now, next up, of course, if we just want to translate up, it's quite trivial. So the resultant function is simply f of x minus 2 plus 2. In particular, if I substitute x equal to 2 here, I would be getting f of 0, because this point is transformed from this 0, 0, and I should therefore get f of 0 here as well, except that it's added by 2, of course. Now, similarly, if I want to dilate the right function by a factor of 3 in x-axis, then obviously the graph would look something like this. It's wider out. But is that supposed to be f of 3x or f of x upon 3? Well, we look at an important point, which say in this case could be 1, 1, or it could be other points, but 1, 1 is the simplest. The meaning of this 1, 1 is really saying that f of 1 is 1. And by dilating, we want f of 3 to be equal to 1, or f of 3 to be f1 of 3 to be equal to f of 1, where this is the original and this is the transform. This is because this point 3, which is dilated from 1, 1, should have a value of y that is same as the original value. Therefore, it's quite clear we want fx upon 3, because in that case, fx upon 3 gives us f of 1 upon f of 3 upon 3 equals to f of 1. So in other words, this new x-coordinate, x prime, is still associated with the right value of y from the original function.